Let's go through LeetCode 3027. Find the number of ways to place people to. Um, this question for 1 and 2, they have the same, they are the same. Only difference is that the data range is different. And it gives us a lot of points. And for these points, um, we want to select to form select the pair of the points to form a rectangle. And the rectangle, we can only, the point should be placed on the top left in the right bottom. So it will form a rectangle like this. And for example, this is a point one, this is a point two, right? And we don't want to have any point on the edge or inside of this rectangle. So it asks how many pairs totally. And also it says that, for example, if the P1 and P2, they have the same x axis, right? It is still valid if there is, for example, P3 outside, still valid rectangle. And also, if they have the y-axis, it will also be valid. So that means this top left, right, and the P1's y should greater equal to P2's y, and the P1's x should smaller equal to P2's x, right? So we know we can do brute force, but the problem is that if we do brute force to choose the point P1 and P2, and also select the rest of point, trying to see whether they are inside this kind of rectangle, it will be ON3 power time complexity. Apparently, it's not good, right? So, what we're thinking about is that we should, if we can have the x-axis or y-axis to be some kind of not monotonic order, we should, maybe we can do better than ON3 time complexity. So what we're thinking about is that we sort this point, right? So that the points they are in x-axis, they are already in uh, monotonic increasing order, right? And for if we have the same, there is 2 points. If um, we have the same x, let's talk about how can we sort the y, right? So to sort the y, we can consider doing like this way, right? So if there is P1, we select that P1. And what we want is that we want to, for example, if this is P2, P3, P4, right? They are in the same, they have same X. So we want to, the point, this, they have Y, um, Y, for this P2 and P3, P4, and they should have y-axis smaller equal to this P1's y-axis, right? And also, for those y smaller equal to P1's one, we just can select only one, right? So if there is an point at this x, we can, which is below equal to this y, right? Then what we want, we can select is for example, the one which is uh, close as this y as possible, right? So, um, the things that, for example, we select at this point x, we select this P2 here, right? So that means we cover this kind of we have a rectangle like this. There is no point inside this. And so so any point have the same x, which is below this P2, should we can ignore, right? Because they will always have the P2 inside it. So will always not be invalid. So what we're thinking about is that we sort x in a ascending order, but sort y in a descending order, right? So that let's look at the what we need to do next, right? So for example, this is P3. Then we go to P4, right? P4, assume this P4 that is have y smaller equal to this P1. And and we know this x apparently will be greater than this P2 or P3's x, right? If they do not equal. But what about the y? The y should, if we select P2, right? Any um any y which is smaller than this P2's y, we are going to smaller or equal to, right? The P2 will be inside this kind of rectangle, right? So that means the previous points we select, we can have a minimal y. That means for the later point we select, as long as our y-axis is smaller or equal to P1's y and greater than the previous minimal y, then we are able to form a rectangle, right? Um, so so that we just for every P1 we have a variable called mean y, right? We use this one, and for the later for example P5 or P6, we need those kind of y p be greater than this minimal py to form a rectangle, right? So that there is no point be inside. Doing like this, we can have two for loop. So um, we this kind of one-sided points is doable, right? So let's write code for this. We need first sort these points. So we are going to have arrays sort points. So we are going to sort it by x, and if axis they are equal, then we are going to sort by y-axis, right? So we are going to if a 0 equals b 0, then we are going to have y compare in a reverse order, as we talk about uh, why we need a reverse order, because if they have same x, right, this is P1, and we if we select the P2, right, P3 which is below of that should we can skip. Otherwise, if we P3 we add one, P2 add one, that will be a wrong answer. And so we compare y in reverse order, and if x-axis does not equal, then we have a x-axis in ascending order, right? So um, so let's have int n equals points dot length. and the result equals to 0, right? And for int I equals 0, I is smaller than n minus 1, I plus plus, and we have current P1, right? P1 is points I. And we need a variable called ymin. Let's set this one ymin equals integer dot mean value. And what we do is that we just for int j equals I plus 1, j is smaller than n, j plus plus, right? So um we're going to what's on this new point. Let's say point 2 equals point 2, right? So let's say if point 2 um firstly, this one need to smaller equal to point 1 dot y-axis, right? And point 2 y is greater than y mean. As we talk about, this is greater, not even we cannot be equal, right? Because if we have P1 and in some of the previous round we have y mean here, right? That means this y mean there is a point. So if it equals, this point will be in the edge of this one, right? So this should be greater than. So if this one is greater than y mean, what we want is we have a result increased by 1, and also y mean equals p2 dot 1, right? So in the end, we just return result. Okay. Um, we also need a Python code for this. So let's points sort um, p equals um, p first sort by x-axis, right? But for y-axis, we should be sorted in a reverse order. Then we're going to have n result in both lengths of points and the result to be 0. So what we do is for I in range n minus 1. So we have let's say P1 equals points I, right? And we have y mean equals float enough. So for j in range I plus 1 to n, right? Then we have P2 equals points j, right? So if we have y mean, which is smaller than P2 dot y-axis and smaller equal to P1, 1, right? This equal is that because even this is a line, same height, right? We still think that is a valid case, like a like this one, right? Still valid case. So then in this case, we are going to have result should pass equal to 1 and y mean equals p2 1. So in the end, we just return result. Doing like this, there is a thought. This is n log n time complexity, but there are two for loop. This is n squared time complexity and constant space